Hello and welcome to the stream, Susie and Brian. I don't have labels up, but folks should be able to hear you. Can we get a test shout out from both of you?
Hi, everybody. Producer Susie here. You guys finally get to see me.
Hi, I'm Brian.
All right, so I am going to hide myself and leave you guys to have a wonderful go before I completely disappear. I will be putting your names up on screen, but I have to be over there to do that. So enjoy. Thank you, Susie, for giving me this chance to go refill my coffee and try and find someplace in my house that's warm. I don't think we have that. I will be back in a bit and I'll be listening in for a little bit. Bye bye.
Bye-bye, Pamela. Go get some coffee. Enjoy.
Bye.
Well, good morning, everybody. Thank you for still being with us or rejoining us this morning on the CosmoQuest Hangout-a-thon. We very much appreciate all of you that are watching, all of you that are donating and giving bits and stuff. We very much appreciate it. And we promise to give you every dollar's worth of what you donate. So this morning, I have the wonderful Brian Koberlein, who is a scientist, and he also happens to be one of the folks that comes on our weekly space hangout and tells us about all of the wonderful space news of the week. So that's what we're going to talk about. But first, Brian, tell us where people can find you and what you do.
Oh, well, what I do is I'm an astrophysicist. I work as a science writer for the National Radio Astronomy Observatory, and you can find me there. You can also find me on Forbes sometimes when I write articles, but mostly you can find me just on my website, which is briankoberlein.com. So basically, everything that can go there goes there.
Well, that sounds fantastic. And definitely, folks, go find him. His articles are great. And we very much enjoy having him come on the Weekly Space Hangout and telling us his take on science stories. But one thing about being a science communicator is that you often get some crazy questions, especially like sitting next to someone on a plane and they find out what you do. You probably get some crazy ones. So let's hear some of those stories that you've heard, or the ones you're maybe tired of hearing and you want answered. And let's move on to cool stuff.
You want me to tell some stories?
Yes, please.
Okay, so I mean, the airport thing is an interesting aspect because there's usually two responses. You know, if they find out what you do and you say, well, I'm an astronomer, I'm a physicist or whatever, and then I think the most common one is, oh, I hated that.
And then I was terrible in that subject.
I was terrible in that subject. Yeah, I found that it depends on if I'm in a mood to talk or not. You know, like sometimes you're willing to talk for a while, and sometimes you're like, no, I just want to put on my headphones and get home. So if I don't want people to talk, I tell them I'm a physicist. And if I am willing to talk, I'll tell them I'm an astronomer. Because they like astronomy, but they don't like physics, even though it's the same thing.
Most lay people just don't know that it's the same thing and that it's just a slight difference in title, but you're doing all the same cool stuff.
Right. I mean, it's funny because when you say, you know, I do astronomy, I work for the Radio Observatory, and people will say, you know, oh, so you must spend all of your time, you know, behind a telescope. And I go, oh God, no, I spend all of my time in front of a computer.
Yeah. They have this old-fashioned image of what an astronomer does. And I mean, I'll admit, I did too until I started being around Pamela and Fraser and all of these folks. Because you get this image of, you know, a person up in the middle of the night in a cold observatory, you know, looking through the telescope. And it's like, no, you spend all your time at a computer.
Yeah, I think it's actually even worse than that. It's the crooked telescope with the cat and the wizard hat,
yes.
You know, and you got a little crystal ball by the side because you're doing the majory stuff, you know. Yeah, that's not what we do.
So tell us, so when you do feel like talking, what do people tend to ask you about?
It's pretty varied. I mean, a lot of it will tend to focus on what is it that you do, what's radio astronomy, what does that mean, blah blah blah. So it's a lot of like, so what about this? So what about this? Because again, people think astronomy is optical astronomy. You know, the other thing is they think that if you work in astronomy, you're connected to everything in astronomy. You know, so it's like you say, well, I work for the radio observatory, and say, well, have you ever used time on the Hubble Space Telescope? No, that's a completely different thing. You know,
No, that's an optical telescope.
that's an
Yeah.
optical telescope and it's a space telescope, and they're very different. And I think the other thing too is that people don't realize that a lot of this data is relatively public, although sometimes they don't go out of their way to make it easy to find, but it's available there, so you can use data from all of these different places. So it's like I don't use any observatory time. Even when I do research, I just don't use any observatory time because all the data is just there. I just go, and I'm like the hyena that goes after the attack, after the lions take down the data. I just go in later and scavenge and kind of scare off the vultures so I can get a little bit of data, because there's just so much there.
Well, that's the best thing about how most programs are publicly funded, so they put it out so you have
Right.
access to it.
Right. And I think that's one of those things that a lot of people don't recognize, because every now and then you will get someone who's kind of a conspiracy theorist and will go, the earth is flat, or, they didn't really land on the moon, or, they're just faking these images, that NASA is faking these images. And you try to explain to them, well, if they're doing that, they're also faking terabytes and petabytes of raw data that they put up.
And not just from NASA. They're faking data from Russia and Europe, and
exactly.
Everybody's faking the data the same way. Okay.
Yeah, they think it's all NASA too. It's always NASA that does everything. It's like, no, I don't work for NASA. So then how do you work with? I work for a completely different organization. So but generally they're pretty nice. I mean, sometimes they get kind of hostile and they want to do kind of gotcha questions like, how old is the universe? Okay, contradict me. While they're pulling out things and going, it's 6,000 years old. No, it's not. But usually it's just trying to explain what you do. There's like, so what does that mean? I've never been familiar with that. So can you explain it to me? But that's kind of most of them.
But I can definitely see how sometimes you might just want to put your headphones in and relax.
Yeah, there are times. I mean, it's like
we've all been on that flight.
Well, it's also that it really depends upon the nature of the flight. I think when you go to different observatories, they can be a 4-hour flight or they can be a 10-hour flight. It's like if you've gone down to Chile for 2 weeks and you're coming back, it's like, I don't want to talk to anybody. I don't even want to know what I smell like. It's just put me in the corner and let me fall asleep the entire trip.
It's like, I just want to get home and take a shower at my own house and
exactly
sleep in my own
there's
bed.
This thing. It's like I just want to use my own room for a while and sleep. But it's there's just a lot of variety to it. But it's but more of the interactions I get are actually over email and things like that. That's usually where you get the more interesting questions.
Well, what are some of the interesting ones you've gotten that you were particularly entertained by?
Okay, so the one I was most entertained by was a particular person who declared on my website that the Earth was flat. Because I had written a blog post that was basically, it wasn't attacking flat earthers. It was just saying, there are people out there that say the Earth is flat, and then just went into this thing of, this is a good question. That knowing that the Earth is round is hard-won knowledge. It's thousands of years ago hard-won knowledge, but it was still hard-won knowledge. And so you could go through, this is how we know. So I got this angry comment on my blog, and it was, the Earth is flat and you need to stop lying to people. And this person continued to go on, and so finally they got blocked there. So then they went to Google Plus when that was still around and started trolling the comments there saying the same things. Then they tracked down my Facebook and my Twitter account and I blocked them both there. So then this person tracked down my place of employment, which was RIT at the time, emailed my department chair and the president of the institution to say that I was lying to the public and needed to be fired.
This is someone who needed a hobby.
This person had moxie, I said.
Whew.
So yeah, it was kind of amusing to go into a meeting and have to explain, you're right, I'm terrorizing the public by telling them that the earth is round.
Yeah.
Like, why would you do what?
Darn you in physics.
Yeah.
Yeah.
So, but some of them are amusing. They have the revolutionary idea that proves that Einstein is wrong. The ones I'm really kind of amused by are the ones that I've come up with this great idea, and you go through it, and you go, you're right. That is a good idea, because in 1800, this particular astronomer proposed that.
Yep.
And so it's, you try and use that as a learning moment to go, yes, you've discovered something, and it was your discovery. It was also discovered 200 years ago, and the new evidence showed that it didn't work, but that's okay.
But you were thinking the right way.
You were thinking,
and that's good.
It's those I think are the most interesting and entertaining. It's the ones that they're sure that you're wrong, and they want to take the gloves off and immediately attack you. If I were part of the conspiracy to cover everything up, I should get paid more.
We should all get paid more.
Yeah,
for sure.
Yeah.
I have a quick question, or question/comment before we move on, about when you were at Rochester Institute of Technology.
Yep.
Our own Nancy Graziano in the Weekly Space Hangout crew is an alumni of there. And so she wanted to know, was Destler president at the time that happened? Because she would love to have seen his reaction to calling you in and having to have that discussion.
Yes. He didn't call me in for the discussion. He sent an email that my department chair forwarded, and I had to meet with my department chair.
As well, he should have. That was definitely a meeting terse. That should have been an email.
It was just this terse, please have Brian explain this situation to see how it must be dealt with, or something like that. And then I had this meeting where it's like, I said the earth was round. See the emails? Why would that person say the earth is flat? Oh, you have no idea.
It's like, yeah. Until you were in more of this science media world, you don't realize how many people out there do want to come and try to say, oh, yeah, the earth is flat. Yes. I honestly had no idea until I was around all of our streams, Astronomy Cast and Weekly Space Hangout, and Daily Space isn't so bad. That's a really good thing. But we also have really good moderators for all of the streams. But yeah, had no idea how many people are out there with these ideas until you start talking about it in a media format where they can talk back at you. Right.
Yeah, I mean, the weirdest one was the whole electric universe thing.
Oh, explain that one. So I don't think I've heard that one.
This is one of those that is weird because it's a kind of a coalition of many different things, and then it overlaps so many things. So in part, the electric universe stems from the idea of the first studies of plasma in outer space, and magnetohydrodynamics, which is how plasma moves in space with magnetic fields, and connects to the kind of alternative views of redshift, the kind of steady state universe that Hoyle and others kind of proposed back in the day. And this kind of plasma physics, which is legitimate. And okay, people thought about the steady state universe and it didn't work out. Okay. And then there's this thing called the Thunderbolts Project. And basically it's a couple of guys that argued that in kind of ancient historical texts, there's always these mentions of, the sky going on fire and the gods throwing lightning bolts down, and, these great Battle of Gilgamesh type of stuff, and
Real mythology going on.
yeah, the whole mythology of that, and the argument that they started off with was that many of these things were based on real events. So there really were lightning bolts coming from space and striking the Earth, and Jupiter had this huge halo of magnetic field, and just weird things that you look at a glyph on a lithograph on some stone, and it looks like they've got little flames out of their head, and the standard interpretation is it's some indication of divine connection or magical whatever, the animus of those mythologies. It's like, no, those are actually plasma things, and this built into this whole idea that things like nuclear fusion doesn't occur in the core of a star, that stars are powered like electric light bulbs, that these magnetic fields have currents that go through them and then cause the star to ignite, and that's how it's powered, by these great plasma currents in the universe, and it explains everything. So general relativity is wrong, the Big Bang is wrong, special relativity is wrong, all of these current things, and
everything is wrong. And as Venera says in the chat, it's a Tesla universe.
It's a Tesla universe. Yes, it's a Tesla universe. And that's a good analogy, because you'll get, and it's interesting because it's mostly engineers. It's a lot of mechanical and electrical engineers that I can kind of understand. There's the idea that all battle plans die on the battlefield. All plans of war die on the battlefield. All theories of physics die in the lab. Because you're doing these things. It's like, well, it's supposed to do that. I don't know why it's doing that. Well, kick it. Oh, now it works. Okay, fine. And I think it kind of builds this idea among engineers that the physicists really don't know anything that they're talking about. That the real knowledge is being able to just get a feel for it in the lab. And so they'll do these little experiments and say, this explains everything. So they'll have like a plasma ball thing over these glass balls that has the plasma arcs, you can like put your hands on it and stuff. Yeah. And they'll see, how these things make these discharges on little spots, and those spots drift. And they'll say, well, see, those are like sunspots. Like, oh, okay. There can be similarities between the two. It's like, so therefore, sunspots are caused by plasma arcs. No,
I don't think so, but maybe they look similar.
Well, that's the thing. I've referred to it as the quacks like a duck syndrome, where it quacks like a duck, it looks like a duck, therefore it must be a duck. It's like, well,
and that's a leap.
Yeah, and
that's a bit of a logical leap. Yeah.
And it's obvious that it looks like this, therefore it's obvious, and the mathematics doesn't matter, but their experience matters. It's like your experience is all mathematical and not in the lab, so you don't know anything. But I've done plasma arc welding, so I know that those crevasses in Mars are caused by plasma discharge.
And that anecdotal evidence is going to convince me that you're wrong.
Yes. and if you don't believe them, you don't have an open mind. It's like, so it's an interesting thing that pops up every now and then, and it's not very popular. So it's one of those things that every time at a presentation, I mean, the last Dragon Con I was at, there was someone there that started talking about things, and you're going, oh, you mean the electric universe thing? Well, actually, yeah. Well, no, because this, and this, and no, it's not true. And, and then everybody else on the panel was like, what are you talking about? Oh, I've been dealing with this for years.
I can see how maybe Tunguska would get them going on that as well. Just the idea of that happening.
Well, and it's, in some sense, it's frustrating because they're clearly curious.
Right.
There's something that's driving that interest, because it's not, like some of the people that will say the earth is flat will say, well, I just don't believe it. They haven't really studied it. It's just, the whole idea of planets and orbital motion just doesn't make sense to them. So the Earth is flat. That's kind of intuitively how I think.
Right.
And they're not thinking deeply about it.
Yeah, there's no scientific curiosity in there. Whereas,
right, it's just
the electric universe. Yeah, that you can see that they're trying to come up with a theory to kind of tie everything together. It's just down the wrong path.
Right. And you got to hand it to the people who are fans of the electric universe. They try hard. they do background research, and they'll refer to some astrophysical phenomena, and you're like, wait, what is that? You do a kind of background search. Like, oh, okay, yeah, I see where you're going with that.
Yeah, Muga Fuga in the chat says the electric universe thing sounds good until you say it out loud. And Larry Weird says, my grandson is an electric universe proponent. Oh boy. So point him over to Brian.
It's interesting. There's a couple of links. If you dig deep enough on Google, you can find a couple of things. One is a page that's dedicated to me as the ignoble Professor Koberlein for lying about certain things in the electric universe.
How dare you lie about physics?
I know. And it's one of those things where it's like I did a blog post based on a specific book that was available freely and went through and criticized point in that book, and then was harped at because that book is not representative of what the electric universe is. Well, what is? Well, go look at these things, and they contradict each other and stuff. But the other one that impressed me was, what was it? There's is it Prezi, the presentation thing?
Prezi, yeah.
Prezi, okay.
I know my kids end up having to use that in school a lot. So
okay, so somebody got so obsessed with me because one of the things is that in the electric universe it says there's no fusion in the core. And when I first criticized that, I said, well, if there's no fusion, then you're not seeing neutrinos. And here's solar neutrinos that we've detected. And they would come back about how you're lying. We didn't say no fusion. We said no fusion in the core.
So even there's like fusion somewhere else?
Yeah, in the ionosphere. So the fusion is happening in the ionosphere. And you're trying to figure out, it's like, well, what do you mean by that? And then they would go on and on about how I lied. But this one guy did a Prezi thing that it's like an A1 size sheet that goes down and quotes things from the website and my blog and Google Plus and rebuts comments that I make of comments of comments.
Wow. It's like a presentation poster.
It's a huge thing. It's impressive. It's like, wow, you spent all of this time. Why?
To do that.
To do that. But yeah, but they dig deep. They're very curious and adamant about this.
Well, what is your next favorite thing then? Because the electric universe was new to me. That was a new rabbit hole. So what is your next one?
I guess one of them that's kind of fun is you get the type of questions of, if you could go faster than light, what would it look like? They always follow. If you could break this law of physics, what do the laws of physics say?
And you're like,
would be about everything else.
You're like, they're already broken.
And it's like, well, okay, which rules in which ways do I get to cheat? Which is, it can be kind of fun to deal with if they're, if they're just kind of curious about that, or, people will ask about, like how, like some movie, is this accurate? And one of the amusing ones was the movie Gravity, which had the whole all the spaceships blow up and she has
everything in the same orbit. Yeah.
Yes.
Yeah.
And it was funny because somebody said, well, you know about this stuff. Could that actually happen? And I said, well, no, basically if the space shuttle blew up, whoever was around there would just die. They would asphyxiate. There's no way to get to another space station or whatever. And it's like the whole, I said that, like, the whole idea of going to the Chinese space station, is just the orbits don't match up. It's nonsense. And this person said, I knew it. I knew the Chinese space station was nonsense. I said, no, that's real. You just couldn't get to it.
It's really there, but you probably just wouldn't even see it.
Exactly.
It's in such a different location. Yeah. All
so
that
they were
stuff
okay
would
with
not
the
be
orbital
together.
differences, but the Chinese space station, that was nonsense. They knew it was fiction. So you get those kinds of things, or you'll get questions about how could you possibly watch a movie that's bad.
Then you'd never watch any movies if that was a problem.
And it's one of those things of how could you watch this movie when the physics is so bad? It's like attractive men and women doing kick-ass things. I'm okay with this.
Sometimes you're just watching for the action or the people that are in it. I mean,
exactly.
I had Mika McKinnon on last night and we were talking disaster science and we talked about the Marvel universe and the snap. Yeah. Talk about science not really working.
I don't care.
I don't care. It's superheroes fighting. There's big stuff going on and people we like. So
that's right.
Yeah.
Thor picks up the hammer again. I am worthy. Yep. Yes. Okay, I'm good with that.
Cat picks up the hammer, and I'm like, yes, I knew it.
I knew it. Yeah, there is that kind of thing where you can suspend disbelief, and I think for me, a lot of it is if you give a hand waving argument to go, it's just this, and move on. I'm okay with that. It's like, we're tossing up some technobabble. Let's move on because we're dealing with the plot. That I don't have a problem with. Do whatever you want. It's when you try and make it really technical in the real world that I get a little bugged with. When you have something that it's like, no, this is actually what we can. No. Just say tachyons, time travel, spacesuits. It's quantum something. I'm okay with that. But it's when you try and make it very, very technical that it bugs me a bit.
Yeah, don't make the technical stuff the plot. Make that the side stuff and then go do something interesting.
Yeah, and I will admit there are times when I have been upset about movies. I actually am guilty of yelling in a movie theater and kind of regret it. It was the fourth Indiana Jones movie where there's
the refrigerator
test going off and he climbs into the refrigerator.
Yeah.
And it wasn't that he climbed into the refrigerator and survived. Okay, fine. It's that they specifically showed the shot that the refrigerator is lead lined.
Yeah. Why go that far? Just
you can do ballistics, you can create an atomic test, but don't violate thermodynamics. Come on.
Just don't even do that. And talking about nearly yelling out during a movie, Pamela, Annie, and I were on vacation last week, and we went to Disney World, and we went to Epcot to the Mission Space ride. And for people who have already heard the story, you know where I'm going. But if you haven't, so we're in there, and they're talking about, we're going to take a rocket to space and go to Mars. And they're saying the rocket's powered by solid hydrogen. And Annie jumps. We're standing in line with random people. And Annie's like, no, that's not how this works. That's not how any of this works. And we're just dying because she's in there doing that. She just couldn't help it. And so we ended up having to do a podcast about how that was not how that worked.
Yeah. There are some things that are
moments.
Too far. It's like, there's so many things I can take and then not, or there are things that I can take that violate physics if they're cool.
Right.
If you make it cool, I'm okay with that. That forgives so many sins.
Yeah, if it's sufficiently cool and interesting and drives the story well, okay, I'll buy it. It'll work.
Right.
I did have a question for you from the chat. I'm trying to catch them today because they go by really fast.
Right.
So, from Larry Weird, what is the state of the art of cold fusion? Just a faded dream of the electrochemists?
The last I have heard of cold fusion is there are still some people trying to make it work. There's no solid evidence that it would work. Quite honestly, cold fusion would be cool, but I just love to see fusion work. If you could get fusion within, say, the size of your bedroom, then that would be so incredibly revolutionary.
That would be, give it many practical applications.
Right, exactly.
Yeah, we could switch to that.
Fusion doesn't have a lot of radioactive waste. It's easy to deal with. It's a lot of power. If you could make it portable and safe, we don't need cold fusion. Just get the fusion done.
Yeah,
and we know that works.
And then we could reduce, our dependence on all kinds of things and have amazing power that we could just take with us everywhere.
Right. And that's really kind of, people think about like all the different challenges that we have. Energy is probably the biggest challenge that we have, because if you have enough readily accessible energy, the limitations are much more minimal than if you don't. There's a lot of things, desalinization, or like just if you have enough cheap energy, just do it. It's just It's energy cost, it's not cost effective by energy, but if you can just force it, there's so many things you could brute force.
Right.
You have basically limitless energy.
Because like you said, with desalinization, we have plenty of water. Most of it has salt in it.
Right.
So if you have the power to desalinize it easily, then you have almost unlimited water there.
Exactly. It's a small fraction that's clean water. And things like recycling or more efficient mining or everything is built based on being able to have power.
While I've got a couple of questions up,
yes.
Let me say, can you comment on warp drive and the inertial dampeners? And this comes from the very appropriate named The Expendable Red Shirt.
Warp drive is an interesting thing. It's one of those ideas that shows up actually in general relativity. There is I'll never pronounce his name correctly. The Acerbe drive. I'm not sure how to answer.
Yes, Pamela knows how to do that. I don't know how to pronounce it, but I know what you're talking about.
There was a legitimate scientific paper that looked at how you could warp space in such a way that you could warp space around the spaceship so it goes from one point to another faster than regular light, and it works. It's valid within general relativity as long as you have this exotic matter that kind of has a negative energy density. If you could come up with that, then you could make warp drive. And so there's, when people talk about warp drive, there's nothing in general relativity that warp drive seems to violate. General relativity by itself seems to be okay with warp drive. But general relativity is okay with a lot of things like time travel and all sorts of things like that. But the challenge is the quantum side of things and the matter. Like the matter energy, that's what seems to be problematic for that. So, I'm one of these people that goes, I can't prove it wrong. I hope they're right, because then we actually could travel to the stars in reasonable ways. But who knows? The inertial dampeners are, you got to love the inertial dampeners because they have what we call plot delay. So they work, they prevent you from turning into a puddle. But apparently when something happens unexpectedly, there's just a fraction of a second where they take to engage so that you can be jostled a bit.
Just so you can do the
you can do the
dramatic movement. Yes.
Exactly. So that's just kind of an interesting little plot thing. But there are all these ideas that we come up with in science fiction that are close, they're tantalizingly close to real physical ideas. Star Trek is known for this, warp drive, teleportation. These are all things that show up in real physics. And when you look at them deeply, they really focus on some of the most difficult aspects of physics and theoretical physics that we can try to understand.
And carbonaceous 14 in the chat says, and the expanse makes you go splat.
The expanse makes you go splat. That's exactly it. Yeah.
Which, that I remember that scene, and we recently rewatched because we're getting ready to watch season 4, and saying, that was definitely a bug on the windshield moment where you really appreciate physics.
Yep. Momentum is conserved. Okay.
Yes. It's one of those. Okay, they went there. Well, right now I'm not seeing any other questions. So tell me some of your favorite ones that you haven't gotten to yet.
It's interesting getting back to the kind of science fiction ideas. I like when science fiction gets some things right. It's one of those things that it's so rare that when it happens, it stands out.
It's like, yes,
you got it right. They actually got that right, and I remember, I think the first time where I really noticed it in not something like 2001 that was kind of trying to be pretty accurate, but a real kind of science fiction movie was Contact, where, in this vehicle that Ellie is in, the whole thing is just shaking, and this little compass floats up in front of her. And what's interesting is that when I was watching that the first time, she looks at it, and then she makes a realization that there isn't gravity in the container that she's in. She needs to unbuckle.
Not be restrained in the chair because the chair was shaking her to the point of endangering her.
It was a great moment for me because the first time I watched that movie, I saw it float up, and my realization of what it meant and her realization of what it meant happened at the same time.
Oh, yeah.
Like, it's floating. She needs to get, and then she realized, I got to get out of here. But those little things that do that, when they do, not having sound in space. And this has become, I think, more popular, where they do space shots and the only sounds they have are inside the spacesuit. And so you can still have sound, but it's clearly not the sound of space.
Right.
And so they get that right. Or they'll get docking maneuvers right, that actually dock in the right way. And, the Expanse is pretty good with this in terms of acceleration. I get the magnetic boots means that we don't have to suspend everybody by cables, and that helps with budget. I get it, but that's always some fun things to see. And it reminds me of probably, in terms of television, one of my favorite sci-fi series is Stargate.
Yes.
Because even though they had this exotic science fiction, they had the Stargates, and you're basically teleporting across the universe, they generally stayed pretty close to whatever rule they came up with, they stuck with. And when they built upon that, they built upon the ideas that they already had. So they minimized, like, they would only introduce a rule when they really had to for a plot point.
And then they remembered it.
And then they remembered it. It's like the Stargates can only open for a certain amount of time, and they stuck with that. And then in the later series, they would have other things that they would build upon, chain a couple of them together, have one time delayed because it's close to a black hole, all of the different things that it's like, this is actually reasonably consistent, for this kind of schlocky science fiction show. It was, a really good way to deal with it, basically.
And I was happy because they had good representations of scientists and women, and
yes,
Stargate is definitely worth a rewatch. If you've watched it in the past, and if you haven't watched it, everybody should go watch it because it's amazing, and it's one of my favorites. I know it's one of Pamela's. I think she just recently did a rewatch.
Yeah.
And Mika McKinnon, who we had on last night, worked on that show as some of the science. So people we know work on there. That's pretty cool. But yes.
And it is a good, for its time, there is some dated things, and there are lines that you just kind of cringe over, but by and large, it was a positive view of science fiction, and it was, it portrayed members of the military well, it portrayed scientists well, it portrayed the goals of exploration well. It was in some sense the continuation of that Star Trek vision that started so long ago.
The expendable red shirt has another question.
Okay.
Providing we harness fusion and create fusion reactors and drives, how are we going to best handle the issue of reaction mass? Will the reaction mass still be water, or will it be something else?
That depends. Water is really good because it's plentiful. So that's one. It could also just be plasma. If you just have ionized particles, you can do them. It really depends on, what type of drive you want to do. Are you wanting to escape a gravitational well where you need a lot of power fairly quickly? Or are you just wanting to get somewhere? Because in just getting the amount of energy to go from one place to another, a plasma drive works really well. It's just slow and steady wins the race.
Right. But that's if you're going on a long trip, you can take that slow and steady
You can take that
acceleration.
slow and steady time. That's exactly it. Particularly for if you're doing things like asteroid mining. You don't need it to come in 2 weeks. And in fact, you probably don't want it to come in 2 weeks. It's just a lot of wasted energy.
No, you want to be able to get it there and then slow it down appropriately.
And then slow it down, right. So you could actually just put a plasma drive on it, send a couple of tons, and in a year and a half, it'll get to Earth. That's perfectly fine.
Let me see if I think I saw another question or two. Okay, 2 questions related about the Martian. So Guido Bibra says the Martian has few deliberate inaccuracies, but on the whole, it's the best exploration movie yet, he thinks.
Mm-hmm.
And let's see, someone else asked, Jen McAllister says, was the movie The Martian close? So give your opinion on The Martian.
Okay, so yeah, there are some inaccuracies that are blatant. One of which is the storm at the beginning. Just
the windstorm.
The wind. There's not enough air density for that to be a problem. But that's if it gets the story going, and it's a difficult thing to understand. Having wind but not having the same pressure as on Earth. It's like having gravity on a planet but not having the same gravity as Earth. It's just hard for us to wrap our head around because we haven't had a lot of experience with that. What I like The Martian because it stayed reasonably close, and the violations that it made were not nonsense violations. In other words, they pushed the point with the wind. There's some other things of being able to seal off something with just open plastic and it's still fluttering. It's like, okay, that's not very accurate. But given the idea of trying to raise food, trying to survive, trying to make a journey, what that actually entails, I liked. What I really liked about the story more than anything else is that all of the challenges are based upon science, exploration, and nature. So even when you have people in conflict as to how to solve a problem, neither side is bad, neither side is evil. You see these debates that happen in the movie and in the story, but these debates are about taking a certain point of view. What risk do you take and what type of risk do you take? And those controversies, neither side is the bad guy. The bad guy is nature. The bad guy is just the challenge of trying to live on an alien environment. So it's a remarkably positive outlook on the challenges of space exploration in a way in which competent people can disagree, which certainly in science fiction is rarely shown, where you have, they have a point, you also have a point, and different people can rationally take different positions.
And that's what healthy debate should be, because, you can have different perspectives, and especially if you don't know the science, it's a new situation.
Right.
Nobody is 100% right in that. So you need to be able to balance those ideas off each other to try to figure out what might work the best.
Right.
because it was a really good depiction of when we get there, there are going to be things that happen that we have no idea how to deal with.
Right.
And you're going to need the kind of people that can just sit there and figure out how to get through each challenge
Right.
and not, not lose their mind and go crazy, but sit there and go, all right, I got to science the bleep out of this.
Right.
So I thought that was a really, really good depiction of, all right, I'm not going to give up. I'm going to sit here and I'm going to think through everything I can think through to figure things out. And all of the people back on Earth are having to think through all of the things. Similar to when we had Apollo 13.
Mm-hmm.
You had the astronauts in the capsule trying to figure things out. And then you had all the people back on Earth going, all right, here's what we have as our resources. We've got to figure out how to make this work so these guys can come home alive.
Exactly.
And that's the great example of a real situation that happened. So
Right.
I thought that was really, really good in The Martian. And then one other thing, and I'll stop giving my opinion on stuff, but I enjoyed the fact that the science changed between when Andy Weir wrote the book and the movie came out about water on Mars.
Yep.
Because we had him on the Weekly Space Hangout and Fraser interviewed him, and he talked about how, if I'd known then what I know now, he wouldn't have had to do the extreme things that he was doing to try to get water, because now we know it's much easier to find.
It's much easier to get water. Yeah, no, that's exactly it. And that's always the thing about any type of science fiction that's based in evidence that we know. If it's not just science fantasy, it's like we learn more things, and then the science fiction becomes wrong.
And it's really cool because that is a fairly recent discovery, and you start seeing how we are discovering different things rapidly. I always make a point, I've got 2 teenagers, so I always make a point of going, guys, this happened like this year. We discovered this changed since you were in middle school to high school or something, and how fast things can change and how fast our understanding can adjust, and how science is never still. There's always new stuff being discovered.
Yep.
That's probably my favorite part about being science adjacent here the way I am, is I get to hear all this stuff when it gets first discovered.
Yeah, and it just keeps coming down the pipeline.
A question for you from Larry Weird about The Expanse, getting back to that. So how far off from The Expanse Epstein's drive, how far off is it compared to fusion rockets? Can a fusion rocket do 1G to Neptune in a single stage from Mars orbit, for example?
So my understanding of the Epstein rocket is that it's basically a plot ploy to make the drives as efficient as they can theoretically be possible, and then a little bit more. So I think if you do the math, it's actually a bit more efficient than you would otherwise. Doing 1G drives is something that's possible. It's a matter of energy thing. So it's if you're accelerating for 1G, shorter distances are more effective than longer distances. Basically, if you're accelerating at 1G, the longer you go, the more mass ratio you need, because you're accelerating longer and faster. And so, a 1G thing to the moon orbit and back, we could probably do. Mars, probably not, given any technology that we know. But, you could also do things of 1/4 G. That could be possible. People forget that like 1 gravity is actually pretty strong for a gravitational field. Of all the other terrestrial planets, Venus kind of comes close, but the other ones don't. The moon doesn't. So typically in space travel, doing 1/4 of a G or 1/3 of a G might be more common. And that could be, we don't know, but that could be enough to prevent some of the health hazards.
And still be efficient with your
be efficient.
Engines.
Right.
Yeah.
Right. So, 1G is normalized, but we've only had the experience of either Earth gravity or nothing. And even the 1-year study that we did with astronauts, was nothing. There was no, well, how much, if we do half a G, if we do a third of a G, does that prevent a lot of the problems that you would have in terms of muscle loss and bone loss and, deviations of the eyes and things like that. That's something we're still trying to figure out. We just don't know. And because we also haven't looked at the comparison of having gravity versus not in space, we don't even know how much of the health issues are definitely due to gravitational weight or due to radiation issues or the quality of the habitat. We just don't know. So there's just a ton of research that still needs to be done. Got to start building that space station and spinning it so we have artificial gravity then.
So we can start pulling out these variables and kind of narrow it down and figure out exactly what is it that's causing the problem.
Exactly. Yeah. Exactly. So, we know making gravity is pretty easy. It's just a matter of spinning things.
Yeah. And this is one thing that will potentially creating a base on the moon to operate from, because the moon has what, 1/6 Earth?
About 1/6. Yep.
So that would be a microgravity, but not zero environment that you could do a lot of tests in.
Right. You can also dig down, and so you can kind of shield away from most of the radiation that's there. So you can have long-term habitats underground in which you're not getting constant levels of radiation exposure. And that's, that's where the moon dust comes in, which is just, horrible, like asbestos stuff. That's just bad.
Yes, I was talking to Jordana Fraser yesterday about moon dust, and she was talking about how it's actually, little pieces of iron and little pieces of basically glass and stuff with all the little sharp edges, and it just sounds terrible.
It's like little razor blades. I mean, I think when you think about things like asbestos, and it's those hard surfaces that would cut into your lungs when you would breathe it.
Yeah,
that's probably the closest analogy. That it is probably as toxic as asbestos. Because,
and so we're going to have really good technology to keep that from getting into everything.
Right. And we currently don't have any such technology. The dust gets everywhere. And so that's a difficult challenge.
I'm looking really quickly to see if I see any other questions. Not right now. So let's see. Have you seen the movie For All Mankind?
The TV show?
Yes, the TV show.
I have not.
I have not either.
That's on my list of things, but I've heard some good things about it. I think it's probably overly optimistic. I know the one criticism I've read about is this idea that if only we had more gumption, we'd be on Mars. And while
gumption and science.
Yeah, and I think there's a thing that people have to kind of keep in mind that at the time when we were doing the moon landing, the NASA budget was more than 1% of the entire GDP of the United States. It was a huge, huge project. And it was never designed to be sustainable.
Right. It was a push to a goal.
Right. I mean, we talk about like 1% for NASA, but we mean 1% of NASA's budget, not 1% of the GDP.
Right.
And so, the moon landing was this huge Cold War project. It was almost a continuation of World War II in terms of its scope. And it was never going to be sustainable. It was never designed to be sustainable. And the things that they built to get there weren't sustainable. So the fact that it's taken this many years to start seriously thinking about landing again is not unexpected at all. If you spend everything to touch the planet and then you don't have any backup, well, of course that's not going to work. Yes, it would have been nice to have more budget for NASA. Yes, it would have been nice to have more political will, but that wouldn't have gotten us to Mars by 1980. That was not going to happen. They're radically different. The science wasn't there. Really, it's surprising that we even successfully got to the moon,
Right.
given how difficult it was and how impossible it was.
I mean, it was a crazy sprint, not a marathon.
It was a crazy sprint. That's exactly it. And I think we find it difficult to look on a much longer timeline. And people forget that in 1960, we had basically had 60 years of air flight. And then we went to the moon.
Yeah.
We are only at the point where we were starting to fly a little bit more than a century ago. So we're only in the first century of powered flight. We're doing pretty good.
Yeah.
I know I'm impatient. I want to go to the stars in my lifetime.
I want to go to Mars. I want to go to all these places. Exactly.
Right. But how long did it take to explore the oceans? If you talk about,
we're not done yet.
Yeah, just Viking raids from one to the other across the sea and navigating, that is nothing like sailing around the world. That is a completely different level of things, and when you look at, the history of sea navigation, for example, when you see the Polynesians, you see the Vikings, you see others that were actually doing really, really impressive things, and it still didn't take and spread until centuries later, because those challenges that can take you so far can't take you the next step, that there are these huge leaps. So we're sending things into space. We're sending people into space. We can reach the moon. That's great. But there are still huge challenges that we haven't even begun to touch.
Yeah, like the radiation challenge. It's like
the radiation challenge, it's like one of the things of the moon landing, they just happened to be at a time when there was low solar activity. So they didn't have the problems that they would have in high solar activity. If there had been a large solar flare, they would have died on the moon. There wasn't enough shielding to deal with it because they couldn't carry enough shielding. Those are the types of things that we were very fortunate to be able to do. So in many ways, we're ahead of the game with the moon landing.
I want to say real quick to Tom Van Scotter, thank you so much for the $50 tip. We appreciate that.
Thank you. Yes, absolutely.
And let me give a last call for a couple of stories. We're going to talk for a few minutes until Pamela shows up and she's ready to take over on that. So if anybody else has any questions, and if not, tell me another one of your favorite things, Brian. I think I could sit here and talk with you about this all day.
It's interesting. So related to the idea of space travel and everything, when I was little, I had this dream of being able to go to Mars because they talked about humans going to Mars around 2000. And I would have been about 30. I would have been the right age to be part of the early Mars missions. And that hasn't happened. I'm not going to Mars, almost certainly. Elon Musk may have differing opinions, but I'm not going to Mars. But when you've been around a while, you start getting a context of how far we have actually gone. So when I was a child, I had this book that was called Our Universe. It's a National Geographic thing full of all these color pictures. And the picture that they had of Pluto was literally this pixelated little thing where you could see a little blob and then go, that's Charon. That little bubble means that Pluto has a moon. And now I can download these huge high resolution images of the surface of Pluto that I can use on a computer wallpaper. When Carl Sagan was around, he talked about this idea of life being among the stars, of all the billions and billions of stars. Perhaps there are civilizations out there like us. In his lifetime, there were no known exoplanets. None. We thought there would probably be exoplanets out there. None had been discovered. And now it's like, we got another few hundred exoplanets today.
Yeah.
That's nice. Yeah.
Trying to think, how many are we currently up to?
I think we're over 4,000.
I was thinking so. Yeah.
We have so many exoplanets now, we can actually start running statistics. And with the new satellites that are out there, like Gaia and others, we're going to find exponentially more. I mean, it's just continuing. This is probably the last few years where you can say, what is the number, and know what the number is, because it's only a few thousand. And then we're going to get to the point where it's like, oh yeah, there's 1 million exoplanets.
Right.
Okay. Just because we know all of those. And we're already starting to be able to run statistics on things like that. The fact that we've detected gravitational waves. When I was in graduate school, there was this idea, if only we could detect gravitational waves. And I had professors like, we're never going to detect gravitational waves. They're just too weak. We'll get indirect evidence. That's nice, but we're never going to get direct gravitational waves. We've done all these things. So even though we're all eager to kind of go to the 22nd century, the fact that we're in the 21st century, we're doing amazing things given our primitive tools that we still use.
And it is just fascinating how much it changes every day. When we pull up, we pull up and just see our press releases and stuff every day. It's like, wow, that is really cool. And Sci-Fi Laura, who's one of our guests that's going to be coming up to play games with Pamela in a little while, just says, currently there are 4,104 confirmed exoplanets, according to the exoplanets at nasa.gov.
Yeah, the fact that you can do that is just amazing. It's really, and it's one of those things that you start, it's hard to remember how quickly radical discoveries become commonplace. We've only been doing gravitational astronomy for a few years, and it's like, we found another. Oh, there's another one. We need to get a bigger telescope so we can do more stuff. It's only been a few years.
It's only been a few years.
Yeah, it's been a couple of decades. We've only had exoplanets for a couple of decades. We're all up to 4,000 now. There's another. These are radical things, but we don't notice them because they're always around.
I am just checking with Pamela to let her know we're good until she's ready.
Okay.
And I'm here. I just forgot to unmute, so you couldn't hear me initially.
Ah.
And we just had another donation come in. Thank you, Bill Smith,
Thank you.
Stargazer. Thank you so much. Do I have a dog? I don't have a dog. I lost my dogs. They're making bacon upstairs.
That is a good reason to lose the dogs. I would go upstairs for bacon too.
So, yeah.
Yes. Yeah, I saw in the message that y'all were making bacon, and I was like, nobody's making bacon in my house.
This is the problem with remote call-ins.
Yes.
Somebody has food and they're not sharing.
I know. You had all the maple cookies last night, Pamela, and none got sent to my house.
That's the technology I want.
I'm saving a box for you.
Okay, great.
We have the ability to make this happen.
Well, thank you so much, Brian, for being with us.
Thank you.
I could literally talk to you about this at least for a couple of hours, but we're going to be letting you go now so you can get back to it. And we have other folks to come on, but I will see you in emails regularly, and we will see you on Weekly Space Hangout. And once again, tell people where they can find you.
So they can find me on my website, which is briankoberlein.com, also at NRAO and Forbes, and sometimes Universe Today. So you expect me when you see me. That's kind of the thing.
We will definitely do that. And okay, Pamela, I'm going to turn it back over to you, and I'm going to go play D&D for a while.
That is awesome. Okay. I'll see you all later.
Bye.
Bye-bye. So I